Welcome back to the lecture series of ICSE 9th Maths. Chapter is Simultaneous Linear Equation. This is the last video of the same chapter. We were doing the problem sums based on this, and in the previous video I covered till type number 7. Today we are going to start with few remaining types. Start with type number 8. Okay. So type number 8 is problems based on boat and stream. So a sailor goes 8 km downstream in 40 minutes and returns back to the starting point in 1 hour. Find the speed of the sailor in still water and the speed of the current. So understand that when the water is still, that time whatever will be the speed of the boat, if the current is flowing and the boat is also going in the same direction, that is called as downstream. Because if the boat is going in this direction, suppose the boat is going in this direction and the current, the stream, that is the current is also flowing in this direction, then the speed of the boat will increase. This current speed will assist the speed of the boat. This direction the boat is going and this direction the speed of the stream or current. Then it will assist the boat and it is called as, this situation is called as downstream. Okay, where the effective speed of the boat increases. Okay, here the speed of the boat increases, right? And if the boat is going in this direction, okay, and the current is on this direction, in the opposite direction, that time the current will be opposing the speed of the boat, and this condition is called as upstream, where the speed of the boat will decrease. Okay, so this is the concept of downstream and upstream. Now let us see what is the sum they are saying. Okay, so they are saying that a sailor goes 8 km downstream. So first I'll make a column of downstream. Here the distance is equal to 8 km and in 40 minutes, the time is given 40 minutes. I can convert it into hour. 40 upon 60 hour, and that is equal to 2/3 hour, and returns back to the starting point in 1 hour. So when it returns back, it is upstream. Okay, upstream. So in case of upstream, the distance remains same, that is 8 km, but the time is now 1 hour. Okay, time is 1 hour. Find the speed of the sailor in still water and the speed of the current. So here I'll consider, let the speed of the sailor in still water be x and the speed of current be y. Okay, unit will be kilometer per hour. Okay, now here the speed will be, since it is downstream, the effective speed will increase. So the speed of the boat will be x plus y. Here the speed of the current will get added to the speed of the boat, this much kilometer per hour. And in case of upstream, the speed will get decreased and the effective speed will be x minus y kilometer per hour. Now from here I will be getting one equation if I apply the distance, time and speed formula. So it is like time is equal to distance upon speed, or we can say speed into distance is equal, speed into time is equal to distance, anything. I am writing distance is equal to speed into time. So distance is 8 km, speed is x plus y. So x plus y into time is 2/3 is equal to 8. So this is the first equation we are getting. Let us simplify this. X plus y is equal to 8 into 3/2. 3/2 goes that side. So it is division. So I just reversed it. So 2, 4. So here we are getting x plus y is equal to 12. This is my first equation. Now the same formula, that is distance is equal to speed into time, I apply for the upstream. So here speed is equal to x minus y. Time is equal to 1 is equal to distance is 8 km. So here I am getting x minus y is equal to 8. That is my second equation. Now we just have to solve these two equations. Let me rub this part. Okay, so the two equations I got, x plus y is equal to 12. I'll write it here. X plus y is equal to 12. And the second equation is x minus y is equal to 8. So x minus y is equal to 8. I can see here I can cancel y. So by adding the two equations, I will cancel y. So it will be 2x is equal to 20 or x is equal to 10 km per hour. I considered x as the speed of the sailor, so in still water, so that is 10 km per hour. Now just put the value in the first equation, putting x is equal to 10 in equation 1. So my equation 1 is x plus y is equal to 12. So 10 plus y is equal to 12, or y is equal to 12 minus 10, that is 2 km per hour. So y I considered as the speed of the current, so that is 2 km per hour. Understood? So this way we have to do the sum. So for the concept of upstream and downstream, always understand downstream the speed will increase. So whatever you consider the speed of the boat as, the speed of the current will get added to it. Okay, and for upstream the speed of the current will subtracted. It will be subtracted from the speed of the boat. That is the concept, and then we have to apply the formula of distance, time and speed. Okay, let us go for the next question. The next question is also based on the same concept, upstream and downstream. A motorboat takes 6 hours to cover 100 km downstream and 30 km upstream. So I'll make two columns here. First of all, find the speed of the motorboat and still water, in still water and rate of the stream. Okay, so let speed of motorboat in still water is x km per hour, and rate of stream means again the speed of the stream. Okay, so rate of stream is y km per hour. Now I'll make two columns. One is for downstream and one is for upstream. Okay. Now let's see the question. A motorboat takes 6 hours to cover 100 km downstream. So the distance here is 100 km. The speed in downstream will become x plus y km per hour. The time will be 100 upon x plus y hour in this case. Okay. For the upstream, 30 km upstream. So the distance here is 30 km. The speed will become x minus y km per hour, and in this case the time will become 30 upon x minus y hour. They are saying that a motorboat takes 6 hours to cover 100 km downstream and 30 km upstream. To cover the entire distance, it is taking total 6 hours. That means this time plus this time is equal to 6 hours. So my first equation is, according to the question, my first equation is 100 upon x plus y plus 30 upon x minus y is equal to 6. This is my first equation. Okay. Now see the second question. Second condition. If the motorboat goes 75 km downstream, I am writing it here. I am again making, this is case 2 actually. I am again making a column downstream and upstream. So this is your case 2. Distance is equal to 75 km. Again in downstream we know the speed will be x plus y km per hour, and therefore the time would be 75 upon x plus y hour. Okay. So if the motorboat goes 75 km downstream and returns back, so when it is returning back, the distance will remain same. So here in upstream the distance is again 75 km. Now here the speed will be here the speed will be x minus y km per hour, and the time will be 75 upon x minus y hour. Now see it, 75 km downstream and returns back to its starting point in 8 hours. So total time is taken 8 hours. That means this time plus this time is equal to 8 hours. So here according to the question we can say 75 upon x plus y plus 75 upon x minus y is equal to 8. This is my second equation. So while you solve the first equation and second equation, you get the answer. I already taught you how to solve it. We have to consider 1 upon x plus y is equal to some other alphabet, 1 upon x minus y is equal to some other alphabet. Then we will solve it, and then again we'll substitute the values. Okay, I hope you remember it. Please try it out on your own. Yeah, so you will get the x and y. X is the speed of the motorboat in still water, and y will be the speed of the stream. Okay, so let us start with the next type, and our next type is the problems based on time and work. So 4 men and 4 boys can do a piece of work in 3 days, while 2 men and 5 boys can finish it in 4 days. How long would it take one boy to do it? How long would it take one man to do it? So for this type of questions, we will consider let one boy can do the work in X days. Okay. In these cases, in time and work questions, we have to always find out 1 day's work. Okay. So 1 boy's 1 day's work. Okay. What it will be? It will be 1 upon x. If the boy can finish the work in x days, then in 1 day he can do only 1 upon x part of the work. Okay. So 1 upon x. Similarly, let 1 man can do the work in y days. In this case also we'll find out 1 man's 1 day's work. Therefore 1 man's 1 day's work is equal to 1 upon y. Okay. So now in the first criteria, 4 men and 4 boys. If 1 man can do the work in, if 1 man's 1 day's work is 1 upon y, then 4 men 1 day's work will be 4 upon y, and 4 boys 1 day's work will be 4 upon x, and that will be is equal to 1 upon 3 days, because here they are saying 4 men and 4 boys can do the work in 3 days. Okay, that means 4 men and 4 boys, 1 day's work will be 1 upon 3. So here I'll write 4 men and 4 boys 1 day's work is equal to how much? 1 upon 3. Now see here, if 1 boy can do the work in 1 boy's 1 day's work is 1 upon x, then 4 boys 1 day's work will be 4 upon x. Similarly, if 1 man's 1 day's work is 1 upon y, 4 men's 1 day's work will be 4 upon y. So according to the question, we can write 4 upon x plus 4 upon y is equal to 1 upon 3. This is the first equation, because they can complete their 1 day's work is 1 upon 3. So 4 men's 1 day's work, according to here, it is 4 upon y, 4 boys 1 day's work is 4 upon x, and that will be is equal to 1 upon 3. Similarly, the second criteria, 2 men and 5 boys can finish it in 4 days. Okay, so I am writing it here, 2 men and 5 boys can finish it in how many days? 4 days. Okay, so 2 men and 5 boys 1 day's work is equal to 1 upon 4. And from here, 2 men's 1 day's work will be 2 upon y, 5 boys 1 day's work will be 5 upon x. So 5 upon x plus 2 upon y will be is equal to 1 by 4. This is my second equation. This is my first equation. Okay. So what we can do now here is, we will just take 1 upon x is equal to a and 1 upon y is equal to b. So let us consider 1 upon x is a and 1 upon y is b. So this equation becomes 4a plus 4b is equal to 1 by 3, and the second equation becomes 5a, sorry, this becomes 5a plus 2b is equal to 1 upon 4. Now We can just multiply the second equation by 2 so that the b part will be equal. It get cancelled and then we can find out AB, and then finally we have to again substitute AB to get the answer of x and y. We have done this type of sums solution before also. I hope you will be getting it. So this way we have to do the sums based on time and work. Let us see one more question based on the same concept. 6 men and 8 boys can finish a piece of work in 14 days. So let one man can finish the work in x days. So we'll always find out 1 day's work. Therefore, 1 man's 1 day's work is equal to 1 upon x. 6 men, so 6 means 1 day's work will be 6 upon x. That is fine. And boys, okay, chalo, let us take 1 boy can finish the work in y days. We'll find out 1 day's work. Therefore, 1 boy's 1 day's work is equal to 1 upon y. Now see the first criteria, 6 men and 8 boys can finish the work in 14 days. So if I take 6 men and 8 boys, 1 day's work will be how much? 1 upon 14. Now see from here, 1 means 1 day's work is 1 upon x. So 6 means 1 day's work will be 6 upon x. Similarly, 1 boy's 1 day's work is 1 upon y. So 8 boys 1 day's work will be 8 upon y. So now the equation will become 6 upon x plus 8 upon y is equal to 1 upon 14. This is my first equation. See the second criteria, while 8 men and 12 boys can do it in 10 days. So I am writing it here, 8 men and 12 boys can finish the work in how many days? 10 days. So we'll first find out 1 day's work. Therefore, 8 men and 12 boys, 1 day's work. 1 day's work is equal to 1 upon 10. Now see here, 8 means 1 day's work is 8 upon x. 12 boys 1 day's work is 12 upon y. So we can write 8 upon x plus 12 upon y is equal to 1 upon 10. This is my second equation. Now we need to solve these two equations. Again, 1 upon x is equal to, we'll consider some other alphabet. 1 upon y is equal to some other alphabet, and then we can solve it by any method. Simultaneous linear equation can be solved by substitution method, elimination method, cross multiplication method. All the methods I already taught you. So try it out and find the answer. So we have come to the last type and last sum of this chapter, and the type is based on the geometry. Okay. So in a triangle ABC, there is a triangle ABC. This is a triangle, suppose ABC. The relationship between the three angles are given. C is equal to thrice of B is equal to twice of A plus B. Find the angle. So let us consider, let angle C is equal to X, or I'll consider the angle A and B. Okay. So let us consider angle A is equal to X and angle B is equal to Y. So let us see the first criteria. Angle C is equal to thrice of angle B. So what will be angle C? Angle B we have considered as Y. So angle C is 3 into Y. This is the first thing we are getting. Second thing, if I apply this criteria, that is thrice of B is equal to twice of angle A plus angle B. This criteria. Thrice of B is equal to twice of angle A plus angle B. From here I get thrice of Y is equal to 2 whole into X plus Y. So from here thrice Y is equal to 2X plus 2Y, and therefore I'll get y this side, 3y minus, so y is equal to 2x I get. 3y minus 2y is y. Y is equal to 2x I get. Okay. Now these two relationship I got. Okay. Now from the angle sum property, we know that angle A plus angle B plus angle C is equal to 180 degree. Now angle A I considered as x, angle B is y, and angle C is thrice of y we got, okay, is equal to 180 degree. So x plus 4y we are getting as 180 degree, and y is equal to 2x. So we can substitute with this value here. X plus 4 into 2x is equal to 180 degree. Okay, substituting this value, you can say this is 1. So here this is from 1. Now x plus 8x is equal to 180 degree. 9x is equal to 180 degree. Therefore x is equal to 20 degree. So we got the value of x. X is your A. Okay. So angle A is equal to, we got 20 degree. Now y is equal to twice of x. Angle B, which we considered as y, that is equal to twice of x, that is 2 into 20 degree, that is 40 degree. Okay. And angle C is equal to thrice of y. So y we got 40, so 3 into 40 degree, that is 120 degree. So we got the three angles. A is 20 degree, B is 40 degree, and C is 120 degree. Okay. So here we have completed with the chapter, that is simultaneous linear equation. I have done many sums. Mostly the sums are taken from R.S. Agarwal. So if you pause the video and do the sum on your own, it will be a good practice. If you require anything, any sum, any problem, you can write in the comment section. So accordingly I will reply you. Thank you so much. If you find these videos are beneficial for you, please subscribe the channel and press the like button. Stay tuned. Next video I'll be coming up with a new chapter. Thank you so much.